1.4, Extrema and average rates of change. So we continue on in this section, still working with graphs, still coming up with rich language to describe what we're looking at with graphs so that we can analyze them. For number 1, it says state the intervals where the function is increasing, decreasing, or constant. And then it says support your answer numerically. So the first thing that I need to warn you about with these graphs is that we are reading them from right to left. Or sorry, from left to right, just like you would a word. From left to right. So it's really tempting to look at this part of the graph over here and see this arrow down and think that it's decreasing. But really, if I am thinking about reading this graph from left to right, like I would a word, this part of my graph is going up. The second thing I want to warn you about is that when we're talking about where the function is increasing, decreasing, or constant, we really mean where y is decreasing, increasing, or constant. So when we support our answers, when we are giving intervals, that's our x's. So really we're saying, where is y increasing, decreasing, or constant? And what is the x value when it's doing that? So this first piece of the function that I've already identified as increasing, we know that this end of my graph goes to, on the left-hand side, to negative infinity. And it goes up to this point right here. And that point, if I trace it down to my x-axis, is at -2. So my graph is going to be increasing from negative infinity to -2. Our convention when we look at these intervals on a graph are to use soft parentheses for everything, because we don't know, does the -2 get included with this piece of the graph or with the next piece of the graph? Where do the brackets go? Where do the parentheses go? So we just use the soft parentheses for everything. The next piece of my graph, as I continue on from left to right, is just flat. So I am staying constant. So my constant part of the graph, using soft parentheses again, is from -2 to this spot over here, which correlates to 4 on my x-axis. So again, my y is increasing from negative infinity to -2 for x. My graph is constant, my y is constant when x is from -2 to 4. So we're looking at what is the y doing, and then where on x is it doing that. So now to finish off my graph, I am going down. So it's decreasing. And it will be decreasing, the y is decreasing from when x is 4 to positive infinity. So again, we're reading graphs from left to right. We're stating the intervals where y is increasing and decreasing or constant, and the intervals that we're giving are x. On the next page, we're looking at critical points. So critical points include extrema, like relative maximum or minimum, and the other name for relative is local. Some textbooks use relative, some use local. I'll use both. And then absolute maximum or minimum. And then the next thing that we also need to worry about is points of inflection. So points of inflection are not a max or min, but they do show a change in direction. So first I want to draw you a picture that shows the difference between absolute and relative. So with this W function, we can tell that this point down here at the bottom is absolutely the lowest point on the graph. So that is going to be my absolute minimum. But there's a point over here where it's not exactly the lowest part on the graph, but it's lower than all of the points around it. It's relatively low when you look at all those other points. So this is going to be my relative or local minimum. I could draw you a picture to show you maximum also, but I think you get it by looking at minimum, what maximum would look like. A point of inflection, I always think of when I think of like a cubic graph, and I kind of change direction in the middle at that point, but it's not really a maximum or a minimum. That is a point of inflection. So again, it's giving us more language to talk about a graph. So sometimes we'll be asked to estimate maximums or minimums and then classify them as well. So I see a minimum right here on my graph. And if I'm trying to estimate it, I need to figure out the scale. Let's see, this is 10, so I must be going up by 2s, 2, 4, 6, 8, 10. And it's maybe a little bit more than halfway between 0 and -2. So I'm going to call it -1.5. So when x is -1.5 and my y is 2, 4, 6, 8, that is going to be a minimum. So now I have to decide, is that an absolute minimum or a local minimum? So is that the absolute lowest point on my graph? If I look at this part over here, it's going down and down forever to -infinity. So this is going to be a relative minimum. It's not going to be an absolute. So then I've got this point over here. And it's worth saying also that it's a relative minimum of 8 at x equals -1.5. I think that's a really good distinction. My other one looks like it happens pretty close to 2 for x, and then 10, 12, 14, maybe 14.5. So 2, 14.5. And it's a maximum. And we need to decide again, is it a relative or absolute? So when I'm looking to see if there's a higher point on the graph, I see that this one over here goes up and up forever. So I'm going to call it a relative or local max. And we want to remember again that the maximum is actually the 14.5, and it occurs at x equals 2. So last thing I notice here is that I do have this point in the middle where I'm changing direction. So I have a point of inflection, and my point of inflection is at 0, 0. Average rate of change. So average rate of change is really going to be something familiar. The average rate of change between any 2 points in the graph of f is the slope of the line through these points. So let's think about our slope formula. We used to have an x1 and a y1 and an x2 and a y2, and we go through and do our slope. M equals y2 minus y1 over x2 minus x1. But now, because we're really using function notation, we have x1 and then f of x1. We have x2 and f of x2. So we're doing the same kind of thing, but we're going to start out with x, and we're going to have to evaluate our function to find the y. And so our slope formula, just like before, it was y2 minus y1. Now we'll have f of x sub 2 minus f of x sub 1 over x2 minus x1. So for our last problem, we're going to calculate the average rate of change. They give us an interval. It's hard brackets, so we know we can actually have those numbers, and those are going to be our values for x. So in order to do our slope, we're going to have to find f of -3. We're going to have to find f of 1. So when x is -3, let's find f of -3, which means we're going to be doing, let's see, -2 times -3 squared plus 4 times -3 plus 6. So we're going to go through and work all of this out. So now we have -2 times 9 minus 12 plus 6. Let's go ahead and multiply. So -30 plus 6 would be a -24. So we have the ordered pair -3, -24. Now I have to find my function when x is -1. So let's go ahead and start, and we'll find f of -1. So we'll be doing -2 times Negative 1 squared. I guess I could have done synthetic substitution also. That might have been faster. Negative 1 squared is 1, so we'll have negative 2 times 1 is negative 2. Minus 4 plus 6, this one's a little faster. We come up with 0. So now we're going to go ahead and find our slope. So our slope will be, and let's write this one as an ordered pair, negative 1, 0. So our y2 minus y1, so 0 minus negative 24. And then x2 minus x1, so negative 1 minus negative 3. So let's see, that'll be 24 divided by 2, or 12. So our average rate of change is going to be 12. Please check in with me if you have any questions at all. I will see you in class.